In problem 1, we are going to look at graphing rational equations. Rational equations are equations that contain a fraction. So, we want to find the domain, horizontal and vertical intercepts, asymptotes, and then we want to verify our graph in Desmos, which I will let you do on your own. So I'm going to start by determining the domain. I'm going to scroll down a bit here so I have a bit more room to work. So the domain, we cannot divide by 0. So we are going to identify the numbers that would make the denominator equal to 0 and eliminate them from the domain. So I'm just taking the denominator and setting it equal to 0. So x equals 7 is the only number not allowed in our domain. So our domain is going to be every number in the world, negative infinity up to 7, but not including 7. So it's every number in the world except for 7. And that's how you're going to write it. You'll just always have that soft bracket on 7. So the horizontal intercept, that is where we want to set y equal to 0. So we're setting our equation equal to 0 for the horizontal intercept. I'm going to multiply both sides by x minus 7 and I get 0 equals 4x. So 0 is equal to x. Therefore, our horizontal intercept is going to be at 0, 0. For our vertical intercept, we're going to plug 0 in for x. Y equals 4 times 0 over 0 minus 7, which equals 0 over a negative 7, or 0. So our vertical and horizontal intercepts are going to be the same. They're both at 0, 0. I'll go ahead and plot that. We know the graph is going to cross there. Now some new terminology, the horizontal and vertical asymptotes. There are some rules about the horizontal asymptote. I'm going to scroll up so you can look at them. Right above problem 1. So we're looking at the end behavior of the graph. What happens as x approaches infinity? What happens as x approaches negative infinity? And there are some trends that you'll see. If the degree of the numerator, the top, is less than the degree of the denominator, the horizontal asymptote is at y equals 0. So if we had an x squared on top and a simple x on the bottom, our horizontal asymptote, x squared on the bottom and an x on the top, our horizontal asymptote would be at y equals 0. Now if the degree in the numerator is greater, then there is no horizontal asymptote. That is definitely possible. So if we did have that x squared on the top and an x on the bottom, there would be no horizontal asymptote. Now this third one is the situation we're in right now, where the degrees are the same. We have x to the first power, x to the first power. What we're going to do is look at the ratio of the coefficients of the highest degree terms. So we're looking at the number attached to the x. So the number attached to the x on top is a 4. And this is for our horizontal asymptotes. And the number attached to the bottom is an invisible 1. So our horizontal asymptote is going to be 4. It's horizontal, so it's going to be y equals 4. Now just to be clear, an intercept is a point. So that's why we have 0, 0 as our intercepts. An asymptote is a line. So I'm actually going to graph the line. Just kind of dotted line here. Y equals 4. Now these asymptotes are going to help us to graph our equation by giving us some guidelines as to what our functions should be going towards. Finally, we have our vertical asymptote. Vertical asymptote's not too bad. The vertical asymptote is the number that is not allowed in your domain. So our vertical asymptote is going to be, and it goes up and down, so it's going to be an x equals 7. There are some caveats to that, but those caveats are not covered in this class. For the purposes of intermediate algebra, that is going to be our vertical asymptote. You'll learn more about this in college algebra if you take that class. So here is our vertical asymptote. So our graph is going to look something like this. So we have one part of it that's going to be up here, kind of straddling those lines. I know you don't see very much of it up there, but that's okay. And then down here, it's going to look like this. And you can look in Desmos again for a more accurate graph, but it should be basically in this kind of shape. Let's do part B. We're going to start by finding the domain. What will make the denominator equal to 0, because we do not want that number in our domain. 7x plus 9 equals 0. 7x equals negative 9. X equals a negative 9/7. So our domain is going to be every number in the world except negative 9/7. Soft brackets on those negative 9/7. Now let's find our horizontal intercept. Horizontal intercept, we are setting y equal to 0 and solving for x. I'm going to multiply both sides by 7x plus 9, and we get 0 equals negative 3x. Divide both sides by negative 3, and we get 0 equals x. So our horizontal intercept is at 0, 0 again. Let's check our vertical. So in this one, we are setting x equal to 0 and solving for y. We get 0 over 9 or 0 again. So our vertical intercept is also at 0, 0. I'll go ahead and mark that just so I don't forget to. Just means that our graph will be passing through that point. Horizontal asymptote. The degree on the top is the same as the degree on the bottom, so we're taking the ratio of the coefficients. Our horizontal asymptote is going to be at negative 3/7, and that is going to be equal to y because it's a horizontal asymptote. Vertical asymptote is the number that is not allowed in our domain. It's always going to be x, and x equals negative 9/7. So negative 9/7, it's just less than 1. And negative 3/7 is just less than a half. So our graph should look something like this. We're going to have 1 on one side, and it's going to go through the origin. And then we're going to have 1 opposite of it, and it will be over here. And again, you can check Desmos for a more accurate graph.